Hello, everyone. Let me go ahead and open my presentation. So now you have heard about what the WSPEC competition is all about. So we want you to participate in this endeavor and also build space elevator prototypes and participate in these competitions. So here's how to start this kind of university team and our experiences in building these advanced prototypes as students for many years now. So quickly to me, I'm a mechanical engineer and now studying aerospace engineering at the Technical University of Munich. And I was the leader of the WARR Space Elevator Team for some time, and then the chairman of the WARR, which is this scientific work group for rocketry and spaceflight at TUM. So it's one of the largest student associations that do space research, not only space elevators, but also rockets and satellites and so on. So we have our own workshop and are basically established as student prototyping organization in these space topics. And therefore, since 2005, we've also been working on space elevators. I will quickly go over the core tasks, what your team has to do to take care of if a student team wants to build a space elevator concept, a climber concept. And then the project schedule, especially with respect to the WSPEC competition. And what resources do you need and how can you take advantage of the university environment and the industry to help you work on this project, and also a bit about member recruitment. How can you motivate students in their free time to work on these projects? So first of all, this is the core tasks about our space elevator teams. I think it applies really to all tech connected projects, but of course you have project management. So you have to handle finance and your schedule, right? So the more advanced challenge with this is that you actually need to sell something that people are not really buying, but they need to sponsor you or help you out in this prototyping events, and I will come to that later. And then you have the systems engineering that do integration and testing. And I mean, this is really where in this student level competitions, you really also get to do hands-on work and work on your project. So you go from design to also assembly, manufacturing, testing, and so on. So for the hardware design, I broke it down and also into drivetrain and structure, because this is different kinds of expertise and also manufacturing. So depending on the opportunities that you have as a university and a team, it's also quite interesting to look into the manufacturing itself. And then software development, where this is mostly embedded and electronics related as well. I will quickly also go over cost, because it's an interesting topic. And as I said, especially for this kind of student team and university development, cost is always a problem. So here is just a slight breakdown of climber cost, which we estimated based on what we've been doing before, but also adapted slightly to the WSPEC goals. Because as I said, we have been working on the space elevator for quite some time, so we can of course go back to older iterations, reuse engineering ideas, reuse parts, and have connections there. So this is a very easy breakdown. So I mean, of course, you need motors and the whole drive system, and you need structure and manufacturing. So these are the most expensive ones, because you need to have the metal parts, or even pay a company to do the manufacturing for you. And a drive system also includes the motor controller and batteries, which are making up the drivetrain and could be quite expensive. But I will come to that later when I talk also about collaborations with companies, which is very interesting, especially to cut down the cost of manufacturing and structure parts. But also how you can save cost is do the manufacturing yourself as good as possible. And this includes as well 3D printing. Especially for the prototyping and testing, this could really be easy since 3D printing is quite accessible nowadays. And then stick to custom off-the-shelf, to commercial off-the-shelf electronics. So use open source platforms that are out there. This could be cheaper than doing your own electronics, and really get into the design over there, and also helps you with the recruiting, because it's not always easy to have many people working on your project. So if you come back to the task I told you about, quite often there's people who have to take care of more than one task of these at the same time. And if you just stick with open source parts that you can buy and basically plug and play, and just do some integration to your system, this will help you, especially with the ambitious timeline for a 1 year of design for a climber to participate in a climber competition. Speaking of the schedule and the timeline, so this is a breakdown. I will go over it step by step. First of all, you need to set the requirements for your climber design. These will or can be derived from the competition rulebook. So since for this climber design, you will be following a competition rulebook and inputs, you can just follow them for your climber design, but there's also open points where you can get creative and bring your own ideas to it. And then this will be the second level of requirements, where you really define how you want to build your climber, how you want to deal with the problem. And don't underestimate this task. If you have a good requirements, set up, the design process later on will be easier. And then you have conceptual design and design selection. I will just combine these to, let's say, you sit together, you do brainstorming, you do CAD modeling, and then you select your design. So, I mean, this is also the same in companies and startups, but it's just on a shorter time scale, right? So don't get stuck with too many different concepts and then go into too much detail, but really select a concept that fits your requirements, and then try to design this as quickly as possible and get to testing, especially with the competition timeline in mind. Because then you need to do the detailed design and engineering. This includes then the preparation for manufacturing, right? So here is I called it component procurement, right? So keep in mind that this is rapid prototyping. Procurement doesn't have to be procurement. You buy parts from a supplier, but you can really go to the 3D printer and print your stuff, test it out, have easy structural parts like aluminum extrusions, and put them together as kind of a primary structure. This is really something you can do yourself, and I encourage you to also work on this yourself. This is also the reason why we do this as students, is that we learn how to really build the stuff that we design. And this is, I think, very important for engineering. There's always the time when you first built your own part that you designed. And usually the first time it doesn't work, but then you had this kind of realization moment already when you were a student and when you were working on this as a fun project. And later on in the industry, you already have the experience. And then, I mean, the first prototypes and production always comes with a design review. So does it all work? Like kind of what I just mentioned. Does it fit together? Does the assembly work? Are the parts manufacturable? Is there something coming up during, the first actual part design? And then, well, here it's called component fabrication. This is really how a company would do it. So sometimes more of these steps are combined into one, and you just spend a Saturday in a workshop or a work area and work on all this. But then basically after the design review, you go to the manufacturing. So using the real part, of course, if your initial prototype works, you can reuse it. But then here, what is called prototype assembly really goes into how to basically fit everything together. You've been working on electrical design on the software, then you have been working on the hardware. So this is really where you have your motors spin and see the integrated testing together with the control integration, and basically go from part testing to sub-assembly testing to full assembly testing. And then the testing is really important because, of course, the WSPEC, as all the climber competitions that we held or took part in, are kind of a test bed. So, and I can also tell you, we never had a full-scale test before a competition, because also, I mean, the competition has a test track ready for you, and you don't have to set up a full-scale test track before. But of course, you do as much testing as possible, so you don't have to fix, well, easy or fixable things at the competition date when you just really want to integrate the climber and the payload to the climber and drive. And this is, I mean, here you call it simulated environment. So this is kind of what the competition later on is. And here it could go on to the next iteration design. So at WSPEC, this will happen once a year, and then you can really work on your design and go on with your prototype. This is what we've been doing. We participated as the WARR team last year in Japan, and will participate this year again with basically an updated climber version of ours. So what kind of resources do you need to do this? So you need a workspace, you need funding and mentorship or collaboration together with the university, and also documentation. And don't underestimate the documentation, not only because we will, for the application process, require some updates in a certain timeline, so we see the maturity of your project, but also this can really help you get sponsors to fund you or provide you with parts, because sometimes you just the test bed for a sponsor. I can tell you about the Space Elevator Team here in Munich. There's, for example, the opportunity where a company is manufacturing our PCB just because they've never done it before and want to test their capabilities, and then we get the product for free. And this kind of opportunities really are common in the industry. So we'll go over those one by one as well, and show you a bit what our capabilities are, or what you could try to talk to the university about. So we have shared workshops, and also the chairs at universities usually have workshops. So on the right, you see a prototyping workshop in Munich, where a lot of startups and also student teams can use this workspace and just assemble their stuff. They also have machines, metalwork machines, also woodwork, and we, as a sponsorship by them, can use these machines. So there might be this kind of prototyping available also from companies. Companies also have workshops, and we sometimes just get a few parts manufactured for the company when they would have machine downtime anyway. Or what also works is if they have apprenticeship machinists, so they're not allowed to work on their real parts yet, since they're in the apprenticeship, but they need to learn how to use the metal machines. So instead of giving them a dumb part that they usually get from the school and they just manufacture something, so they did it, we provided our parts and had these young apprentices work on our parts. And then instead of them throwing it away because it was just for exercise, they shipped it to us, and we used these metal parts, and we got it for free. So here at the university, we do have our own workshop. So this depends on the resources of the university as well, but usually it's quite easy to get an office or just a space where you're allowed to meet and have basically one big table in the middle and just work on prototypes. So this is the two, at least I can tell you from our experience, it's the two options where you talk to the chair themselves. So here on the left, you see, by the way, the hangar at an airport in Munich. where the chair of space propulsion does the testing. And as I said, our student group also works on rockets. So, for example, we're allowed to test our rocket motors over there. But on the same facility, there's the German Aerospace Center, and they have kind of this huge sandbox for rover testing. So we were there and asked them if we can drive our rover there, because I mean this is not really used 24/7. So they do some tests there. So we could just schedule a test with our rover team and drive a rover around their sandbox, which is like a realistic Mars environment, and test there. So there's always a way to just talk to people and try to try to have them provide their resources to you as well. So this leads to the collaborations. Here a lot of chairs at the university also have workshops, and sometimes they let us use machines or manufacture for us, because compared to the industry, the machines at research institutions are not as tightly scheduled as in the industry. So it might be easier to get some machine time there. And also through the university, we get public funding for research projects that we have to use the university for, but basically there we get public German and Bavarian money. And then at companies, you get sponsorships for parts and manufacturing, sometimes financial sponsorships or donations. The by far easiest of the three is to get parts and manufacturing, because usually companies don't want to just give you money, but if you ask them if they can machine a part for you, that's usually easier. So here I put together just a slight overview over different types of companies that we've been having collaborations with. Sometimes it's easy to get just sample parts. This is for electrical engineering mostly. So you find someone who builds connectors or cables, for example. You just ask them about some samples, or the same goes for computer chips, ICs, for PCB assembly. We, for example, I didn't put that on here, but with Texas Instruments, we write them about some parts that we need for our electronics, and they can, in their system, they just put it as sample, which they give to big companies. And this is a very easy way, without any paperwork, to get components. For Rapid Harness and VistaPoint, the two on top that you see here, this is softwares. So as a product data management for our CAD files, we use the VistaPoint software, which we contacted them about, and basically as a deal, we got the software for free, but also we report about the usage of the software. We tell them about bugs or features that are missing or not working correctly, and this is kind of their value. This is what we give to them in return for free usage of the software. And for Rapid Harness, it's a software to also connected to electrical engineering, where we found the software, and in a free preview version, we saw that this is useful to us, and then we just contacted the company and asked if we can use it for free, and then you basically put the logo on your website as an acknowledgement, and they usually let you use software for free. TQ Motors is an electric motor manufacturer in Germany, and we saw their motors as well, and then we asked if we can use them for our climber. And then, I mean, this is a bit more expensive, so they ask you, can you put the logo then on your climber, and basically work a bit more on the outreach side. But usually there's a deal to make with these companies, but sometimes you get a discount, which already also helps. ESA Aerospace and Aurora Technologies that you see here are actually spin-offs of the student group. So we, of course, stay in close contact, and they give us some sponsorships or donations from time to time, or even a sponsorship of manufacturing parts as well. On the left, the S Plus is actually a German manufacturer of persons elevators, which they approached us about and said, we want to work on our marketing side, on the outreach side, and you are building space elevators. So this is a very cool project. We want to do financial sponsoring. And they have their apprenticeship workshop also in their facility. So these are also the ones that manufactured for us for free through the young students who build our parts. And on the right, you see Sparkasse, which is actually a German bank. This is here to show you that not always technology-related companies are willing to donate money or fund you in some way. But here, especially for the competition that we held, the space elevator competition, the European one that we hosted in Munich, there was a quite easy application to get some donation, and you just acknowledge that the donation for this event came from the bank, and they were willing to give us money as well. So don't focus too much on technology companies, but really just look into companies who could be interested in gaining outreach through you. But of course, in technology related companies, something that you sell is also access to young students who have experience in prototyping, right? So what we also sell for our financial sponsorships are basically a newsletter. So if companies have a job opened, they can just send us the brochure, and then we distribute it in our student team. So they get access to students, to talents, which they're very much interested in. So it put together here an overview. This is what our sponsoring document looks like. This is the one without the numbers, but basically you have different tiers. You can put a price tag on this, and you can offer different types of deliverables for a financial sponsoring or for a part sponsoring. So if you now come back to this cost overview, I would say from this $1,500 parts and manufacturing portion here, you can cut this by quite a lot if some of the manufacturing is done for free as a sponsorship. And then I will also quickly go over recruitment. Here you see events that are hosted by the university. So usually if you ask them, you really can also attend these events. So here on the right-hand side in the picture, you see the desk with our satellite. So this is also from our student group. And then they provide us with a table, and then you can just display your prototypes and get to meet new students who are potential new members for your team and work on your team. But also, this is the president of the TU Munich standing there, so you always keep a close contact to the university itself. And on the left, you see that we can even give presentations. We do kickoff events, basically. So in the start of the semester, we ask the university if we can use a lecture hall, and then after the university time, so 6 p.m., we just invite everybody to come join us for this presentation, and then we show what we're working on and try to recruit new members. Of course, we are a quite established student team, and this should still not stop you from coming up with your own team, right? So just talk to the university, talk to professors that are in the same research field as we are, which can be robotics. It doesn't necessarily have to be a space-related chair, but it can just be robotics or real-time systems, electronics, right? So every time you find just a slight overlap in technology with what we're doing at the Climber and even the power beaming, just contact the chair, and usually they're quite interested in helping out with these research projects. So here I just put again the link for the competition. So there will be everything about the actual registration process, but there will be, as I said, certain steps on the way where there will be submissions of concepts of technical drawings just for us, and maybe a video of a prototype later on, just before the competition, so we can follow up on progress. As I showed in the timeline, maybe there will be some milestones as a deliverable to us if you enroll for the WSPEC Climber Competition, to check the maturity of the project and ensure that later on when we actually hold this competition, there's no surprises, or we can also help out and consult on some topics and guide you a little bit through the process. That's it for my presentation about how to build a team. And since we will go on to the Q&A anyway, I think I will just open it early, and you can use the chat function to ask questions about the three presentations you just heard. Thank you.